As I'm currently working on finishing my website, which is going to be awesome by the way, I decided to listen to a little bit of white noise on YouTube. Normally I would go for some smooth Christmas jazz at this time of year to get in the spirit of things, but I stumbled across something else, and white noise it was indeed. I enjoy watching the videos from DiBeos. The animations are cool, the math is interesting, albeit they don't go as deep into the math as I would like, and I aim to do that in my channel, but nevertheless they are a cool channel. They are much more popular than me, which I don't mind, but with this popularity comes responsibility, and in this recent video that they posted, I'm sorry to say that they are wildly irresponsible in painting the PhD system with a broad brush and an inaccurate one at best. So I'm going to take time out of making my website to correct this recent video that they posted. As a quick disclaimer, I went through the PhD system. I ended up conferring a master's due to some internal financial problems that my lab and the department were going through, but I have no regrets. Everyone was super nice and I enjoyed every minute of my time there. My degree was in physiology and biophysics, and so naturally I was to learn some graduate level math, but only the math necessary for understanding biophysics. This was mainly courses in stochastics. But because I was working in cryogenic electron microscopy, I had the chance to learn more math pertaining to Fourier analysis, LLMs, artificial intelligence, and machine learning. A lot of the AI math was related to understanding how such models could be used to recognize proteins in the raw data that we were getting. I say we because even though this was my project, I think it's important to realize that a PhD is a highly collaborative thing. You work with other people in your lab offering your way of thinking as they impart their wisdom onto you. I read countless books on math involved in understanding ion channels, which is what I was studying. This included statistical thermodynamics, stochastics, and even some nonlinear thermodynamics as well. Other math and physics courses I took were under what was called a fellowship course, or fellowship courses. Here I had more freedom to take some more abstract areas of math that I was interested in. But this did not dissuade me from continuing to try to confer the degree, so I'm currently on a mission to confer that right now. The reality of the matter is that while PhDs might be undergoing something of an inflation problem right now, the degree is still valuable, especially in today's climate. With people in higher education trying to leave the country due to the current political administration, and an increasing number of people quitting their PhDs like DiBeos is describing in his recent video, which we will get into, I think there's going to be an eventual decrease in this inflation problem. Less PhDs will be here, and so their value will begin to increase again. Things always come in waves, just as the great singer-songwriter Jim Croce once said. Nobody ever had a rainbow until he had the rain. Anyways, let's get into deconstructing parts of DiBeos' claim. I think the biggest misunderstanding that DiBeos has here is that a PhD is about the science. The reality is that a PhD is less about the science and more about your discipline and dedication to one thing. A PhD is not about how good your science is, and is not designed to give you an infinite amount of freedom to study whatever you want. I always like to say that meaning doesn't come from doing whatever you want, it comes from how well you can do something given some boundary conditions, to put this in math terms. I'm reminded of an old Jordan Peterson quote on this topic.
Efficiency is built into human experience, and there are existential consequences to that. Now, I read something a long time ago, and I don't remember who wrote it, but it was written about Jewish commentary on the Torah. God is omniscient, omnipotent, and omnipresent. What does he lack? And the answer is limitation. And that's a riddle and an answer of unparalleled brilliance as far as I'm concerned, because I think it speaks deeply to something about the central nature of existence itself, and that is that without limitation, there's no being. Now, that's a hard thing to understand, but I think you can understand it in a number of different ways. The first thing you might want to understand is that I play this game with my students sometimes in my class. I'll come up to a student, or pick them at poor victim at random, and come up to them and say, okay, we're going to play a game. And they say, okay. And I say, well, you move first. Well, they don't know what to do. And the reason for that is because the limiting parameters of the game have not been defined. And as a consequence of that, they're stunned by their infinite freedom into complete immobility. And what that means in a sense is that in the absence of serious constraint, there can be no choice, no freedom, no existence. And I believe this to be fundamentally true, just as the fact that human being is vulnerable is fundamentally true.
And it's true. Given infinite amounts of freedom, you end up not knowing what to do. Given limited freedom, you now can hone in on something to do, and you actually have a higher chance of getting that thing done and not getting distracted from other quote-unquote freedoms. Let's see what DiBeos says about the problem with diversity in the PhD programs.
That only like 5 people in the whole world know about. I love math, and yes, I have my preferred areas, but I still want to be able to explore different angles and different fields and see connections between them. Staying locked into one tiny piece of knowledge for years just kills my motivation. And historically, that kind of wide-ranging curiosity was very common. Look at the greatest minds we admire today. Take Euler, for example. Probably the broadest and arguably greatest mathematician ever. He didn't just revolutionize calculus. He made major contributions in number theory, graph theory, fluid dynamics, mechanics, astronomy, optics, and even music theory. He was not really a specialist in a tiny little field in any sense. Then we have Hilbert. He was one of the people who laid the ground for modern mathematics, but who also made influential contributions to the early development of both general relativity and quantum mechanics. Paul Dirac helped to create quantum mechanics and predicted antimatter, but also worked on general relativity and even statistical theory. Poincaré practically founded topology, contributed to celestial mechanics, and laid the groundwork for chaos theory. Von Neumann, he was into everything: set theory, quantum mechanics, game theory, economics, computing. Then Feynman, quantum electrodynamics, sure, but also superfluidity, computing, nanotechnology, and physics education. And of course, we don't only have to take older examples from decades ago. The greatest mathematician alive today, Terence Tao, is also very unusually broad, being known for his contributions in various distinct mathematical fields.
In talking about diversity, I think DiBeos is also misunderstanding what he's talking about. The truth of the matter is that a PhD is extremely diverse. When I was going through my program, I was able to collaborate with people in neuroscience, physics, computer science, and even in mathematics. So the diversity is there. When DiBeos talks about the lack of diversity, I personally don't think he has thought this all the way through. When going through the many scientists that contributed greatly to many fields, DiBeos neglects to inform us that many of these people got PhDs. Poincaré got his PhD. Euler is speculated to have submitted his PhD back in 1726. David Hilbert earned his PhD in 1885. Paul Dirac and von Neumann earned their PhDs in 1926, and Feynman earned his in 1942. Tao received his in 1996. Yet, they all contributed to a large number of fields. So this lack of diversity that DiBeos talks of, he directly contradicts in bringing up these figures. The diversity is there. Again, it's the extreme amounts of dedication that the PhD awards, not just the science itself. We now get to the famous Freeman Dyson quote.
Mathematician Freeman Dyson said exactly that in this interview. The quote is a bit long, but trust me, it's worth it. The whole PhD system to me is an abomination. I don't have a PhD myself. I feel myself very lucky I didn't have to go through it. I think it's a gross distortion of the educational process. What happens when I'm responsible for a PhD student? The student is condemned to work on a single problem in order to write a thesis, for maybe 2 or 3 years. But my attention span is much shorter than that. I like to work on something intensively for maybe 1 year or less, get it done with, and then go on to something else. All the PhD students had these same constraints imposed on them, which I basically disapprove of. I just don't like the system. I think it is an evil system, and it has ruined many lives. Now, I'm not comparing myself to one of them, obviously, but I think that a lot of mathematicians in general share this kind of curiosity. We love math in general, not just topology, not just partial differential equations. And yes, specialization is
I'll be
inevitable
honest,
to some extent.
there are times
because you
during
can't
my
seriously
academic
study
career where
everything at
Dyson's
once.
words resonated with me, but I eventually grew out of this. Dyson, for as much as a respected physicist as he was, and for as much as I respect him, I think he's wrong on this point, and allow me to explain. Much of this quote is personal. He talks about how his mind was one that liked to bounce between topics, and perhaps a PhD is not for people who have this quality. But oftentimes, especially in today's world, and especially in biophysics of ion channels, you can't just get it done with. You need to go through the countless trials and errors to harvest cells, purify proteins, concentrate the proteins, and then image the proteins. And if you're trying to get a protein complex, the process is exponentially harder because complexes are much less stable and are more likely to fall apart easily. So it's frustrating, but the result can actually be very satisfying, and you do get awarded for persevering through this process. When you get that structure, a sense of elation overcomes you. I experienced this during many intermediary steps during my project. Just look at that purification curve of one of my proteins with EGFP attached to it and M-cherry on the other protein as I was trying to co-purify it. And my PI was excited to see this as well. An evil program that Dyson described would see this project as not worth pursuing. Imagine giving up before you got to this point. You would not be able to pass down your dedicated protocol that you made for this purification to the next person trying to answer the next question about this protein or this protein complex. So I think Dyson is wrong on this. This is not a condemnatory process. It's a hard process and one that rewards perseverance and dedication. When DiBeos starts talking about the career aspect of the PhD system, he describes this as the part of the system that pushed him over the academic edge. The publish or perish notion is true, and unfortunately it leads to some shady science, to say the least. Data falsification, countless hours focused on grants and not science, as well as the mistreatment of students are not new. Throughout my academic career, I would hear horror stories of students crying at their bay in the labs. One thing that I found was pretty disingenuous for DiBeos to say was that he made more money as a waiter than he did as a PhD. I'm reminded of a quote from the well-respected scientist Ann Carpenter in the field of tech bio.
Not after money, we're not after fame. Like, we really just want to make a difference in the world. And to see the software being used throughout academia and industry, and to see the assay having put drugs into clinical trials, like, I mean, there's really nothing like it. And I feel so grateful because, I mean,
there's something to be said for being in a PhD for the science and not the money. The money will follow you if you persevere and don't quit. This is something that I think is hard for many people, including DiBeos, to understand, and I will admit that I have had a hard time with this as well, but I know that as long as I work hard and remain dedicated to what I love doing, I will be rewarded. One thing that I want to pose to all of you is the following. I think that the PhD system is one in which society becomes advanced and not individuals. If I specialize in protein dynamics and you specialize in quantum computing and someone else specializes in general relativity, society as a whole becomes 3 times more specialized, whereas you and I and the other person become specialized in one thing. So the entity that is really benefiting is the group over the individual, which is far better for everyone because then can collaboration occur and people are rewarded for their own perspectives. If one person can become specialized in everything, then there would be no point in collaboration and therefore no sharing of different perspectives. So the person who got the PhD is inherently valuable for his perspective that he offers. And so, you getting a PhD is not about you, it's about how you contribute to society. I recently read the book A PhD is Not Enough by Peter Feibleman, excuse me if I'm mispronouncing that, in which he argues that a PhD is only a stepping stone to becoming successful. You need to do more. Make a website, start a business, write a book, become a motivational speaker. You need to do more to become successful. Anyone who thinks that getting a PhD is going to be the golden ticket to the Nobel Prize like DiBeos does, I think is kind of delusional. In the book Code Breaker by Walter Isaacson, Jennifer Doudna, founder of the CRISPR system, did more than get a PhD to achieve success. Her story of perseverance and making something of what she discovered went beyond just getting her PhD, and this is what needs to be done in order to succeed with a PhD. You need to do more. The unfortunate reality is that we are living in a time where many of us are looking to people like Destiny, Matt Walsh, Candace Owens, David Pacman, and Tucker Carlson. These are people who are not experts in anything. They are not even that smart. We should not be listening to them not only because they wildly distort reality and science, but also because they use this distortion to create unnecessary polarization and hate. While I don't mind the polarization, the distortion of reality is what's frustrating. I personally think that people with PhDs should be more listened to than these people, and I consider myself as a force for pushing society in a direction where people with higher degrees are more respected and listened to. While I do think that there might be some things that could be changed in the PhD system, I think that the system is, by and large, a well-established institution that has been working for centuries. In this sense, I am conservative on the topic of this PhD issue. I know a PhD is not for everyone, but if you find yourself academically inclined or wanting a challenge, I would strongly suggest it. Anyways, that's it for now. Back to working on my website, and I will see you guys in the next video. Bye.